solid revolution and the Washer method. Suppose f of x and g of x are continuous functions, and that f of x is greater than g of x over the interval ab. Let's already note the region bounded above by the graph of f of x and below by the graph of g of x. On the left by the line of x equal a and on the right by the line of x equal b. Then the volume of the solid region formed by revolving R around the x-axis is given by the volume equal to the integral from a to b of the area of the outer disk minus the area of the inner disk times dx, or it is pi times the integral from a to b of f of x squared minus g of x squared dx. So let's do a little bit of visualization. See, here you have a xy coordinate plane, and you have a function, say here f of x, and you have a function of below g of x. Okay. And bounded by x equal a and x equal b. The region that we're looking at is this weird little figure. This is our R. Now if I go ahead and take this and rotate it about the x-axis, then I'll get this figure. Okay. And it's got a hollow in the middle, right? As you can see. So the figure that we get is kind of like a vase, right, with hollow in the middle. And this part here, and let me just color this in. This is our solid here that we're looking at. Okay, so note that to find the volume of that vase, we have to find the volume of the outer edge and then subtract the volume of the one that formed by the inner edge or the hollow. So that's why we have this distance here. Okay, so this is our outer radius, and this is the inner radius. The way we determine the inner and outer radius, the inner radius is the one that is the closest to axis of rotation. So in this case, the axis of rotation is the x-axis. So the inner radius is g of x and the outer radius is f of x. Let's take a look at one example. The region bounded by the curve y equal x squared plus 1 and the line y equal negative x plus 3 is revolved about the x-axis to generate the solid. And so let's go ahead and draw the region first. And we have y equal x squared plus 1. So let's draw that in. So this is the graph of y equal x squared plus 1. The line negative x plus 3. So this is the decreasing line with the y-intercept at 3. Okay, and let's take a look at what is the x-intercept. The x-intercept means the value of x when y equal to 0. So when y equals 0, x equals 3. And so this is the line. Okay. So this is the region that we are looking at. And we'll go ahead and rotate this about the x-axis. So we get something look like this. Okay. So this figure here, it's got a hollow, and it is hollow in the middle. So it looked like a cone that been chopped off a little corner, right? Okay. So first of all, the first step, we will find the intersection of the two curves. So x squared plus 1 equal negative x plus 3, x squared plus x minus 2 equal to 0. So x plus 2 times x minus 1 equal to 0. So the 2x intersection is negative 2 and x equal 1. So then now we will use the integral to calculate this volume. Well, the volume equal pi, evaluate from negative 2 to 1 of the outer radius. The outer radius in this case is negative x plus 3 squared minus the inner radius. The inner radius is the parabola x squared plus 1 squared dx. I'll go ahead and expand this all out. We combine like term. We do the integral. Evaluate from negative 2 to 1, we get 33 pi.